Hello viewers, it's another session for chemistry, and remember we are still looking at what we call organic chemistry, and today we are going to focus on what we call alkenes. Remember, by definition, alkenes are unsaturated hydrocarbons which contain a double bond between carbon-carbon atom. And remember to say there is not a member in this homologous series known as methane. This simply means that the first member in this homologous series is known as ethene, and all members that belong to this homologous series definitely end with their names end with ene, and the first member is considered to be ethene. So ethene becomes the first member in this homologous series where we don't have a member known as methane, and the reason is very simple. Why we don't have a member known as methane? It's because there is no provision where we can put a double bond in the structure formula. So there is not a member known as what? Methane. Hence, this homologous series starts at a member called ethene. So if we have ethene here, we can have what we call propene, which is the second member. Then the third member is known as butane in this homologous series. But in terms of positions or in terms of number of carbon atoms, we're still going to consider this to be 4, this to be 3, this to be 2. But in terms of position in this homologous series, this becomes the first member because there is not a member known as methane, and the reason is very simple. It's because there is no provision for a double bond in this structure formula for methane if it were to exist. But the first member is considered to be ethene. This is the second member. This is our third member. So we have benzene, we have hexane, and we have septane or heptene. So here we can have two members, heptene or septene. Then we have octane, and we have nonene, and we have decene as our last member in this homologous series. So now, this is the series of members that belong to a homologous series known as alkenes. Remember to say, all members that belong to this homologous series, their names end with E-N-E. E-N-E, as guided to a homologous series known as alkenes. Therefore, what else do we need to know about alkenes? Apart from knowing to say their names end with E-N-E, the most important thing that we need to know is that there is not a member called methane in this homologous series. And the third thing that we need to know is knowing the general molecular formula, which is CnH2n. So now we need to understand the general molecular formula of all members that belong to this homologous series. We have the general molecular formula, which is CnH2n. Remember, this general molecular formula belongs to a homologous series known as alkenes. And if we can do a quick recap on alkanes, we are going to say the general molecular formula for alkanes is CnH2n plus A2. So there's a big difference between this general molecular formula for alkanes and this general molecular formula for alkenes. So remember, this is the most important part of all alkenes. So now, what else do we need to know? Apart from considering the general molecular formula for all alkenes, which is CnH2n, remember? CnH2n. What else do we need to know? We need to know on how we can write the structure formula as well as the chemical formula for all the series of members in this homologous series, of which we've been given one very simple example here. And apart from doing the chemical formula and the general molecular, the chemical formula as well as the structure formula, we need also to understand what we call additional reactions that undergo all alkenes. So now, alkenes can undergo some certain additional reaction where we are going to allow hydrogen to react with any member from the series to produce an alkane member. So we are going to do that very simple example just after doing this example, which is asking us to write the chemical formula for propene and pentene. So now, when we want to respond to question A, what is the chemical formula and the structure formula of propane? Definitely, for you to write the structure formula or the chemical formula, you need to understand the general molecular formula for all alkenes, which is CnH2n. Probably, if this is propane, needs to have how many carbon atom, or needs to be considered to be on position number 2, definitely. But in terms of carbon atom, it will be 3. So definitely I'm going to say where there is N, I'll replace by 3, 2, open brackets, it's a 3, then C times 3, it will be C3, this is going to be 6, this becomes the chemical formula for propane. By using the general molecular formula and considering the number of carbon atoms, prop simply means it needs to have 3 carbon atoms. Definitely, the chemical formula for propane will be C3H6. Now, from here now, I need to consider writing the structure formula. Remember that all alkenes are unsaturated hydrocarbons. This simply means that they contain a double bond between carbon-carbon atom. And there are 3 carbon atoms here, so I should write them in a straight chain, just as simple as this. Therefore, I'll say this is a double bond. This is going to be a single bond. Remember, this gives the characteristics of all alkenes, or the feature of all alkenes. Definitely 1, 2, 3, 4. 1, 2, 3, 4. This is 1, 2, 3, 4. Now, hydrogen atoms here, there are 6 hydrogen atoms. So I'll say 1, 2, 3, 4, 5, 6. Just by doing so, I have responded to the chemical formula of propane as well as the structure formula. Remember, these are unsaturated hydrocarbon and a double bond must appear on the structure formula. So let me respond to the structure formula of pentane. How can we write the structure formula of pentane? Pentane is found, or it needs to have 5 carbon atoms. So we are going to say the general molecular formula is CnH2n. Where there is N, I'll say multiply by 5. This is going to be 2, open brackets. This is going to be a 5, C times 5. This is C5, H. This is going to be a 10. This is the chemical formula for pentane. Now, if this is the chemical formula for pentane, therefore, I need also to know, now I can come up with what we call the structure formula. So definitely here, I'll say my C5H H10. This is the chemical formula for pentane. Now, how am I going to draw the structure formula for pentane? So, I need to have 5 carbon atoms in the straight chain. So, there will be a position for a double bond somewhere. Then this is a single bond, single bond, single bond. So, this is going to be like this. Definitely, this is 3, 4, 2, 3, 4. And I'll consider this one, and this is going to be like this. So, this is the structure formula for pentane. So this is 3, 4, 5, 6, 7, 8, 9, 10, indicating 10 hydrogen atoms. Now, when I respond to the example like this, remember, this is just a short lesson about alkenes, and we are only focusing on the chemical formula as well as the structure formula. Then we can also understand some certain additional reactions that all alkenes definitely undergo. So from here now, we have more additional reactions, but for now we are only going to focus on a quick reaction where the members that belong to the alkenes can react with hydrogen to produce an alkane member. For example, when ethene react with hydrogen, we are going to have ethane or ethane. So when ethene react with hydrogen, we are going to produce ethane. What is this process called? This is called hydrogenation. Why is it called hydrogenation? Because hydrogen is reacting with an alkene member to produce an alkane member. Now, under what conditions? There should be a catalyst known as nickel, and there will be a temperature range of about 150 to 200 degrees Celsius. So two conditions, a temperature of about 200 degrees Celsius and a catalyst which is called nickel will allow hydrogenation to take place, where hydrogen is going to react with an alkene member to produce an alkane member. Definitely, the ECZ might demand for the chemical formula of this process known as hydrogenation. So remember, this process is called hydrogenation, where hydrogen react with an alkene member to produce an alkane member. And if they demand for the chemical equation, definitely we need to say this is ethene, C2H4, definitely plus hydrogen, H2. Then we are going to have C2H6. So this is ethane, this is ethene. So definitely this becomes the chemical formula we can draw from hydrogenation. Remember, hydrogenation is just a process where hydrogen reacts with an alkene member to produce an alkane member under the following conditions. Number one, temperature, which is about 200 degrees Celsius, as well as a catalyst known as nickel. So from here now, the ECZ might also demand for what we call structural equation. So you need to understand all these simple concepts. So we are going to say, if we want to come up with a structural equation, we can say this is an alkene member. So we are going to have a double bond like this, very simple. 4 hydrogen atoms here, then plus there are 2 hydrogen molecules here or atoms. So we are going to say we have just a single bond in between. Then to give us, we have C2 here. So we can indicate the structural equation just as simple as this. So this is just a very simple R. So we are going to say a single bond between carbon-carbon atom is the definition for all alkanes. So this is now what we call the structural equation. So it was just a very simple session. Make sure that you follow the page and you tag others who might find this video to be beneficial. Remember, for those of us who are sitting for GCE examination, make sure that we take this topic to be serious, because in every exam paper that comes under chemistry, there's 18 marks for organic chemistry. For now, it's a bye-bye. Stay tuned and follow for more.